in how many ways we can arrange all the letters of the word secondary, secondary. Keep in mind, again, this is a special word which has no repeated letters. Secondary, 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 letters, and I'm putting restriction, that is in how many ways we can arrange all the letters of the word secondary if. And restriction starts, number 1, no restriction. Part 2, all these arrangements begin with S. Third, begin with N and end with Y. Fourth part, all vowels are together. Fifth part, all consonants are together. Sixth part, consonants and vowels appear alternately. Begin with vowel and end with consonant. So these are the restrictions, and with one example, this is a very important example, and it can cover all types of the question regarding restrictions on permutation. In how many ways we can arrange all the letters of the word secondary if there is no restriction. If there is no restriction, just count them, 9. We can write down solution for the first one, 9 factorial or 9p9, same thing. You can use calculator to get this value. 9 factorial means 9 into 10, 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So you can just use calculator to get this value. So first part, no restriction, just simple, as I have given example number 1 and 2, so 9 factorial. And now the second part, now restriction is that all these arrangement, that is 9 letter arrangement, begin with S. What does it mean? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters are there. Restriction is all these must begin with S. So S will be the first letter of all these S. So we are just fixing it. We cannot change this S from this first position. So now how many letters can move? 1, 2, 3, 4, 5, 6, 7, 8. It means 8 letters can move, and the answer is 8 factorial or 8p8, because S is fixed, which cannot move. In the third part, we have to find the number of arrangements in which N is the first letter and Y is the last letter. Again the same way you can draw 1, 2, 3, 4, 5, 6, 7, 8 and 9. First letter is N and last letter is Y. So now we have fixed 2 objects. You can clearly see that it is similar to the part 2. Here we have fixed 1 object, and now we are fixing 2 objects which cannot move. So how many objects can move? 1, 2, 3, 4, 5, 6, 7. 7 factorial or 7p7. That clear? So this is the third part. I repeat, when we are fixing the object, we are reducing the numbers. 9 becomes 8, 9 becomes 7 because we are fixing two objects. Now the next part is together. This is another restriction. First restriction, fixing. These two are similar. We are fixing an object or two object or three object, fixing. They cannot move. Here, together. Together. These are similar question. These two are similar. These two are similar. First restriction, fixing an object. Fixing the object. Second restriction, together. Two objects together, three objects together, four objects together, boys are together, girls are together, alphabets are together, vowels are together, like this. So, how can we just do this? Look at this. In this way, in this question, that is part 4. In part 4, look at this vowels. Vowels, in this, vowels are, you can count vowels. 1, 2, 3, there are 3 vowels over here. You can check again, E, O and A. 3 vowels are there, S, C and D, R, Y. These are consonants. Consonants are the letters which are not vowel. In English alphabets, we have 5 vowels and 21 consonants. So, 3 vowels are there and the question is, vowels are together. Whenever objects are together, we have to make single block and place them in single block like this. E, O and A. E, O and A. And then we have 1, 2, 3, 4, 5, 6 other objects. I repeat, we have to arrange in such a way that vowels are together, E, O and A. I just make them together like this, single block. And then 6 left over, 1, 2, 3, 4, 5, 6. 6 consonants here, 6 consonants. I am not writing. 6 consonants are there. So you can count 1, 2, 3, 4, 5, 6. So what is the way? Way is count the single, this whole block as 1 externally. This is whole block which will move like this. Complete block will be moving. Okay? Here single object will be moving. But here complete block will be moving. So we count 1. Then this is 2, 3, 4, 5, 6, 7. Total 7. 1, this block, and then single. 6 plus 1, that is 7. So 7 factorial. And he said vowels are together. He never said E, O, A together in that order. So if O comes first, then E and then A together. A comes first, O then and then E again together. So how many are there? 3. So 3 factorial, they can arrange themselves by using 3 factorial. So I repeat, whenever we are given objects are together, then make single block for the together and then count 1 and then 1, 2, 3, 4, 5, 6, 7. 7 factorial. And then how many objects are there? 3. And then multiply by 3 factorial. Because they can arrange themselves by 3 factorial. Okay, I can move to the 5th part, which can help you more. In this part, I think there is all this. Now, in this, all consonants are together. How many consonants are there? Check it. We have 6 consonants. 1, 2, 3, 4, 5, 6. You can write in any order. 1, 2, 3, 4, 5, 6. S, C, N, D, R, Y. We can write in any order. So this should be made single block. As I said, together object means consonant together, we have to make single block. And how many vowels are there left over? That is E, O and A. In any order again. First count this 1, 2, 3, 4. Externally we have 4 blocks. 4 factorial. And then internally internally how many? 1, 2, 3, 4, 5, 6. They can arrange themselves in 6 factorial. So we have to multiply by 6 factorial. Look at this. Bubbles are together. Single block 1 and then 2, 3, 4, 5, 6, 7. 7 factorial into 3, 3 factorial. Look at this. 6 single block 1, 2, 3, 4, 4 factorial. How many are there? 6 into 6 factorial. That would be the answer. So whenever we have to just make together and do the question on together, we have to make single block, count externally and then internally. In the next part, consonants and